fire resistance gloves when performing aluminum welding. Configure the setting for continuous TIG mode through pulsing. This is used when performing TIG welding continuously while the foot switch stepped on. In the continuous TIG mode, two vertices inside the corner and plane surface can be chosen. And in the double wire mode, a welding rod of up to 0.8 mm can be chosen. In addition, it is recommended to wear fire resistance gloves when welding in continuous TIG mode. The procedure for setting the time interval between arcs in a continuous TIG mode is as follows. Turning the dial with the time button held down enables to set time. Turn the dial with the time button held down in pulsing mode. Save your own condition settings. Select a user to save and use unique conditions. After turning the current and time dials to choose unique settings, hold down the preset button to save them. To call unique conditions, choose the user with the preset button. In this demonstration, two vertices are welded in the double wire mode. Before performing resistance welding, hold the electrodes and the base material firmly from the top so that they become parallel to each other. First, tack weld the top surface of the damage. With the welding rod holding the top surface of the damage firmly from the top, perform tack welding in order starting from one end. Next, tack weld the side surface. With the welding rod holding the lateral side of the damage firmly, perform tack welding from one end. Next, perform tack welding for preventing shrinkage. Here, shrinkage refers to insufficient dimension caused by the melting of the surrounding area of welded spot during welding. Tack weld the welding rods at both ends in such a way that they protrude outward. The protruding length should be twice the size of the welding rods used. Apply the resistance torch to a place situated at the same distance as the size of the welding rods and perform tack welding. Tack weld the welding rods at both ends of the damage in such a way that they protrude outward. In this case, the welding rods are protruding outward by 0.8 mm. Perform TIG welding. Welding it directly causes the melting of the edge. This is called shrinkage. Use a copper plate to prevent this. Cut the end of the copper plate at an angle. Position the electrode perpendicular to the center of the welding rod. Apply the copper plate to the edge of the welding rod to prevent shrinkage. When performing welding, press the copper plate closely to the welding rod. If the welding rod cannot be welded at one time, move the copper plate slightly away and perform welding again. Change the orientation of the workpiece so that the middle of the electrodes can be welded easily. Weld the electrode between two welding rods at an angle of 45 degrees. Start welding from the ball for shrinkage prevention and the tack-welded welding rod. The electrode should be welded at the same distance as the diameter of the welding rod. In this case, the distance is 0.4 millimeters. At the second and later shots, the electrode should be positioned between the peak of the melted bead and the tack-welded welding rod, while keeping the height of the electrode. Perform non-wire operation to fix insufficient melting or uneven beads. Now, the welding of two vertices are completed. Even though the welded area is polished like this, it can be confirmed that no shrinkage is observed. Now, two vertices are welded in a single wire mode. Position the end of the welding rod at the top surface of the damage and position the electrode at the center of the damage at an angle of 45 degrees. Separate the damage and the electrode away at the same distance as the radius of the welding rod, and keep the same distance as the radius of the welding rod from the welding rod. In this case, the distance is 0.2 millimeters. Apply the end of the welding rod firmly to the base material and perform welding from one end in order. Next, apply the welding rod to the edge to weld the shrink area. Position the welding rod in such a way that it protrudes outward. Perform welding with the electrode positioned vertically between the welded edge and the protruding welding rod. Perform non-wire operation to fix uneven melting. If there is any areas whose welding thickness is insufficient, Apply the welding rod to perform TIG welding additionally. The distance between the welding rod and the electrode should be same as that for the first shot. Now, the weld is completed. Even though the welded area is polished like this, it can be confirmed that no shrinkage is observed. This is the completion of two-vertex repair in a single-wire mode. Now, three-vertex repair is performed in the double-wire mode. Tack wire the welding rods at each edge of the damage as viewed from above in such a way that they protrude outward. The protruding length should be twice the length of the welding rod. In this case, the protruding length is 0.8 mm. Perform tack welding like this. Perform TIG welding. Position the electrode straight to the peak of the damage. The electrode should be located away at the same distance as the size of the welding rod. Cut the end of the copper plate into a V shape and apply it to the edge of the welding rod. Cut the tip of the V shape at an angle to prevent it from contacting the tack-welded welding rods. The two welding rods get together in the middle to create a peak. Even though the welded area is polished, it can be confirmed that no shrinkage is observed. Now, three vertices are welded in a single wire mode. A torch stand is used in this case. Select a welding rod whose size is large enough to conceal the damage. Tack weld the welding rod in such a way that it protrudes outward by the same distance as twice the length of the welding rod. In this case, the welding rod is protruding outward by 0.4 mm. Tack weld the welding rod like this. Perform TIG welding. Position the electrode at the peak to the finished. keep the same distance as the diameter of the welding rod. In this case, the distance is 0.2 millimeters. Position the electrode vertically at the center of the welding rod. Even though the welded area is polished, it can be confirmed that no shrinkage is observed. Now, an inside corner is welded to change the shape. Apply the electrode at an angle to prevent it from becoming thinner than the welding rod. Be sure to round the electrode, or its edge contacts the base material. Perform tack welding to fill the inside corner. Tack weld the inside corner sufficiently, like this. Perform TIG welding. Position the electrode at an angle of 45 degrees